Hello, hi dear students, welcome to our channel Maths with Panindra. In this video, we are going to discuss limits and continuity problems. Let us have a discussion. The first question: if f of x equal to sine of step x by step x for x step x is not equal to 0, f of x equal to 0 for step x equal to 0 is first option continuous at x is equal to 0. Second option discontinuous at x is equal to 0. Third option left hand limit at x is equal to 0. Right hand limit at x is equal to 0 as 1. So particularly it is given left hand limit and right hand limit. But we have to verify whether it is continuous or not by observing the first options. At x is equal to 0, here the function value is 0. At x is equal to 0, f of x is equal to f of 0 equal to 0. X equal to 0 means step x is also 0. Step 0 is 0 only, no? So f of 0 equal to 0. So limit x tends to 0, f of x. When this limit will be exist? Whenever left hand limit and right hand limit will be exist. Left hand limit extends to 0 minus, limit extends to 0 plus f of x. Here f of x will be there. So both left hand, right hand limits. Now we will verify left hand limit extends to 0 minus step x value we will calculate. Limit extends to 0 plus step x value. Limit extends to 0 minus f of x. So f of x means, according to the question, sine step x divided by step x. Here I will explain about x tends to 0 minus. X tends to 0 minus, it implies that x is less than 0. Whenever x is less than 0, here 0, 1, minus 1. X is less than 0 means the value of x in between minus 1 and 0, in the interval minus 1 and 0, the value of step x is equal to minus 1, you remember. So limit x tends to 0 minus sine of step x value minus 1 divided by, so not this step x value only minus 1, no need to write step again. Sine of minus 1, here minus 1. So which is equal to, sine of minus 1 is minus 1. Limit extends to 0 minus sine of minus 1 is constant. So minus sine 1 by minus 1. Sine 1. So left hand limit, once again I will repeat, x tends to 0 minus x is less than 0. Whenever x is less than 0, meaning is in the step x function or greatest integer function, the value of x in between minus 1 and 0. So in between minus 1 and 0, if you take any value of x, it takes only minus 1. So sine of step x equal to sine of minus 1 by, wherever step x is there, you can replace by minus 1. So sine of minus 1 is minus sine 1 by minus 1. Minus 1 get cancelled, sine 1. Similarly, RHL we can apply. Right hand limit. So left hand limit we got sine 1. So in the third option is not possible. We'll go for right hand limit. Limit extends to 0 plus f of x sine step x divided by step x. Limit extends to 0 plus. The meaning of extends to 0 plus is that implies that x is greater than 0. X is greater than 0 means here in the real number line the value of x in between 0 and 1. So step x value it will take as 0. Any value lies between 0 and 1. If you take that value goes to be 0. So whenever step value is 0, sine step x value is also 0 only, no? Sine 0 is 0. So limit extends to 0 plus sine step x by step x value is 0. So therefore 0 by anything is 0. Limit extends to 0 minus f of x is not equal to limit extends to 0 plus f of x is not equal. That means left hand limit and right hand limit is not equal, but right hand limit value is equal to 0. Whenever LHL and RHL are not equal, the given function f of x is discontinuous. F of x is not continuous. Not continuous or discontinuous, both are same at x is equal to 0. So f of x is not continuous, that means discontinuous, which is there in the second option. I hope everyone understands, dear students. We'll move to the next question. The next question. If f is defining from closed interval of -2, 2 to R is defined by f of x equal to square root of 1 plus cx minus square root of 1 minus cx by x for -2 is less than or equal to x is less than 0, x plus 3 by x plus 1 for 0 is less than or equal to x is less than or equal to 2, is continuous on closed interval of -2, 2, then C equal to options 3, 3 by 2, 3 by root 2, 2 by root 3. So here condition is given f of x is continuous on closed interval of -2, 2. In this interval, closed interval of -2, 2, in between 0 is there. Observe here x is less than 0 and here 0 is less than or equal to x. X is less than 0 means x tends to 0 minus, you can take it here. 0 is less than or equal to x means x is greater than or equal to 0. So here you can take as x tends to 0 plus. So f of x is continuous at x is equal to 0. Continuous it is on the closed interval means 0 is belongs to closed interval of -2, 2. F of x is continuous at x is equal to 0. So that is f of 0 is equal to limit extends to 0 f of x. When this limit will be to exist this limit, left hand limit at x is equal to 0, limit extends to 0 minus f of x, limit extends to 0 plus f of x. Both the limits will be exist and equal, then only you will get the value of c. And also limit extends to 0 f of x. F of 0 value how to calculate? F of 0 it is there. X 0 is less than or equal to x is there, no? 0 is less than or equal to x. That means at x is equal to 0. At x is equal to 0, substitute 3 by 1 will come. At x is equal to 0, f of x value First f of x is equal to x plus 3 by x plus 1. X is equal to 0 if you substitute, f of 0 is equal to 0 plus 3 by 0 plus 1, that is equal to 3. So f of 0 value is 3. So here f of 0 value 3. To exist the limit extends to f of x, we need to define both limits left and right. Limit extends to 0 minus f of x is equal to limit extends to 0 plus f of x. So 3 is equal to limit extends to 0 minus means you have to consider this function f of x equal to limit extends to 0 minus f of x means root 1 minus cx minus root here plus 1 minus cx divided by x, which is equal to limit extends to 0 plus f of x. What is f of x here? 0 plus means x is greater than 0. Here I already wrote extends to 0 plus means x plus 3 by x plus 1. Equal to x is equal to 0, substitute in this limit, it will becomes indeterminate form. So to evaluate indeterminate forms, we need to apply L'Hospital rule. So in the numerator and denominator we are going to differentiate. So limit extends to 0 minus root 1 plus cx derivative is 1 by 2 root of 1 plus cx. Again 1 plus cx, if you differentiate, c will come, minus root 1 minus cx derivative is 1 by 2 root over 1 minus cx. Again 1 minus cx derivative is minus c, divided by denominator x derivative is 1, which is equal to x is equal to 0 plus x is equal to 0, substitute 0 plus 3 divided by 0 plus 1. So 3 equal to limit extends to 0 minus c by 2 root of 1 plus cx minus into minus plus c by 2 root of 1 minus cx, which is equal to 3. So 3 equal to limit extends to 0 minus, so no need to write limit extends to 0 minus, directly x is equal to 0, substitute, you will get it as c by 2 into root of 1 plus 0 plus c by 2 into root of 1 minus 0, which is equal to 3. So 3 is equal to c by 2 plus c by 2. Equating these two or these two, that implies that 3 is equal to c. So therefore the value of c is 3. Once again I'll scroll up all the questions. Take that. This is the value of c. Thank you dear students for watching my channel.